If you have two parts that you want to stick together in a non-permanent fashion, one way to do that is with bolts. And when it comes to 3D printing, that usually means you have to have a shape that will cut that hole for the bolt. In this video, I want to talk about how I set up the geometry for this kind of bolt and many others in Blender for 3D printing. I like to add just a cube and merge all the vertices at the center, add a screw modifier. This way I can make just a profile of the hole I want and it'll make it round for me nice and easily. So let me draw this shape. Here's the basic bolt shape, and now for the nut. Now that we have the base geometry, we can move on to updating the dimensions to match the specific bolt that we want to use. In this case, I've got an M3 by 25 metric bolt and 6-sided just standard nut. And so this is a socket head cap screw, so that's why it's got a rectangular profile on the head there. So let's start by explaining why I've got these two steps here. This first part of the screw I'm going to set as the tap drill size, and that would be the diameter, so we could cut threads in the plastic when we're putting the screw in there. We can either use a die or a tap and cut the threads, or we can just force it with a screw. Either works, but both places we get the information from the same place. We need a tap drill chart, just something like this, and go over to the metric sizes and find M3. 0.984 is the diameter. This, because we're using the screw modifier, is going to input as a radius, so 0.0984 divided by 2. Super duper. And then, since this is a M3 screw, it should fit in a 3mm hole. However, just going to check that to make sure. So measuring this screw right here, we can see that it is 0.151 inches. And we go over to Converber, 0.151 is 3.8. So I find it good to just measure and make sure. And we're going to put in, let's round that up by 25 thousandths or so. So that'll be 0.175 divided by 2. And so that should be plenty of space. I like to have this taper between the two different bore sizes so that if we're going to use this as a self-tapping hole, then that lead-in makes it a lot easier to start the screw into it. Otherwise, you're kind of forcing it onto a square edge, and it generally is a lot more difficult. Next, I'm going to measure the diameter of the head, and that's 0.275. I'm going to round that up again to 0.15, so 300 thousandths diameter. And then I'm going to set the lengths. So this is 25 millimeters long, but I'm going to just measure this like that, and it comes out to be 0.98 inches long. So you can just put that into the Z height, 0.98. Nice. And then I'm going to measure the thickness of the head of the screw at 0.152. And this is partially just for keeping track of this when we want to line it up later. If you want the top of the screw to be flush or where that lines up on the geometry you're cutting. The rest of this above the top of the screw is just for clearance. Again, in case your screw is going to be any amount recessed below the surface. Same idea down here is just extended beyond the length, the end of the screw, which would be at the origin of this part. And there we have it. Next, we have to do the same for the nut. This is slightly more tricky because we're going to be trying to measure across the points like that. I'm measuring this as 0.3 inches. So we can put the radius in as 0.15. I like to add a little bit again, 0.175, so another 25 thousandths, just to compensate for allowances on the printer and just make the nut removable. And then again, the thickness of this nut is 0.12. There we go. And again, clearance for this nut as well. What I like to do is keep these off to the side. So just grab them, place them someplace in the file so we can use them later. And then when we want to actually implement a bolt in a location, we just do Shift D. Now we've got a new nut and bolt. And if we modify these to fit the application, then it's not going to ruin our master copy, and we can just make this one custom. There is one thing I like to do, regardless of the application, is improve the geometry for Boolean operators. So I just apply the screw modifier on both, and then both the nut and the screw. And then I look down the axis of the screw and select these central vertices and dissolve them. That leaves flat faces that are a lot easier for the existing Boolean operator to cut, and it also just removes a little bit of extra geometry because these points don't actually line up and merge properly. So super duper. That's how I set up nuts and bolts. Now let's see how to actually use them. Here I've got two parts that I'm cutting a bolt hole through, and you can see I've got this top edge of the bolt here just slightly recessed from the surface of the part I'm cutting it out of. And then I've got the nut, same thing, slightly recessed from the surface on the part I'm cutting it out of. And then you can also see that I'm cutting the bolt hole and the nut cutout out of this part. And then this one, I'm only cutting the bolt with its counter bore. Since I have all of the tolerances and allowances baked into the nut and bolt geometry, I don't need to add any extra offsets here. It just, as it shows on screen, it will theoretically work just fine. The only modification I've done specifically for this hole is I've moved this tapered feature down inside of the nut geometry. That way, the whole entire bore is cut to the clearance size rather than the threaded size, and that just makes it so that when I put the bolt through, it just slides in nicely, and then I can tighten it in the nut rather than in the plastic. So that's how it works on the computer, but the important thing is, does it work in real life? Well, glad you asked. I printed out the parts, and we can actually see how these fit. So I can take the nut and just stick it into the hole and just kind of shove it in there. And then on the other side, we've got this little counter bore, and we can just shove the nut or the bolt right through there. A little bit close, but that prevents wiggling. And then you just bolt these two together. Yeah. And as you can see, it's just slightly recessed from the surface on the bolt side, and on the nut side, it's just slightly up above, like the bolt's just past the surface there. And there you go. That is how to make bolt holes for printing in Blender. Thanks for watching. Oh, and yes, as with any good printed part, this does have a purpose. This whole time I've been recording with my mic just sitting on the top of my water bottle, and it makes it hard to drink water. So now I actually have a real mic stand now, and I can drink my water at the same time. So, cool. See you next time.